Hi, my name is David, and I'm going to talk about separable differential equations. So these are the simplest types of ordinary differential equation, and the general form of a separable differential equation is dy dx equals f of x over g of y. So how do we solve this equation? Well, what we do is we separate the variables, hence the name, and the way we do that is we multiply both sides by g of y dx. And when we do that, you can see we get cancellation on both sides. The dx is on the left cancel, and the g of y is on the right cancel. And what we're left with is g of y dy equals f of x dx. So this is nice. We've separated the variables. Now all we have to do is integrate both sides. So when we integrate both sides, we get the integral of g of y dy equals the integral of f of x dx. But then you have to be a little bit careful, because when you integrate, you're always left with an arbitrary constant, integration constant, on the right. So this is the solution. Integral of g of y dy equals integral of f of x dx plus c. So that's how you solve a general separable differential equation. So let me give you an example. The example I'm going to give you is Malthusian population growth. There was a sociologist in the 18th century named Thomas Malthus, and he came up with a very gloomy prediction on population growth. And I'll show you why it's gloomy in a minute. But anyway, his model was you have dn dt, where n is your population in a given region. So dn dt is just the rate of change of the population with respect to time. And we said this was proportional to the population. So k is just the constant of proportionality, positive constant. Okay. So how do we solve this equation? Well, we solve it the same way we solved the other differential equation. We separate the variables. So in this case, we multiply both sides by dt over n. And as you see, we have cancellation again. dt's cancel on the left side, n's cancel on the right side. And what we're left with is dn over n k dt. Okay? So now we separated the differential equation. The next thing we have to do is integrate both sides. So when you integrate the left side, you get the natural logarithm of n. And when you integrate the right side, you get kt. And then you have to put your integration constant. So you get log n equals kt plus c. The next step is we have to exponentiate both sides. So we're solving for n. The way we do that is we exponentiate the left side. And when we exponentiate log n, you just get n. So we have n of t, and when we exponentiate the right side, we get e to the kt plus c, which we can write as e to the kt times e to the c. And we can rewrite e to the c as n0. N0 is just a positive constant. So we get n0 e to the kt equal to n of t. So that's the solution to the Malthusian population problem. And now the reason this is gloomy is because this is a basically unrestricted population growth. It's exponential. Exponential functions grow very fast, particularly if k is large. So basically what Malthus was saying was that a region undergoing Malthusian population growth will have unlimited growth, but the food supply is limited, so eventually people will start starving. So that's why it's a gloomy prediction. Anyway, that's my lecture. Thank you.